So our final speaker for today is Steve Colt, and he is an economics professor, formerly of UAA, recently now of APU. And Steve has spent several decades researching topics related to ecosystem services and natural resources. And he's known for his ability to tackle cutting-edge projects and also work in an interdisciplinary capacity to look into Alaska issues. So Steve, let's see, and your talk is called Economic Risk to Alaska Communities from Ocean Acidification.
Okay, thank you, Darcy. Thank you all for sticking with the program. An old economist joke is that I know you'll be applauding me because I'm the only thing standing between you and dinner. So you keep that in mind. It's probably used in other disciplines. I'm here basically to recapitulate or deliver the message from a large, to me large, group of us led by the venerable Jeremy Mathis, who really provided the intellectual initiative and creativity that led to this paper that I'm going to talk about. And Sarah Cooley was also a major intellectual contributor. And then, look, there's, I was going to say Bob Foy is on the list of co-authors, but he's not, but Jessica Cross is. So there's a big group of us, and Jeremy got us all together with really an audacious goal of trying to link the little bit that we know about the biochemical effects of ocean acidification to the potential outcomes for Alaska's, not just Alaska's commercial fisheries, but Alaska's commercial and subsistence fisheries, and how changes in those resources or those ecosystem services might actually affect community and human well-being. And I think it was a deliberate overreach. There's really not enough data to give definitive or even directly quantitative answers to these questions. But I was eager to participate when Jeremy called me, because I thought it was really important that we try to begin to assemble the data in ways that can shed some light on what all this stuff might mean for us, Alaskans, living in the environment that's being affected, and for many of us living with a great deal of economic, social, or cultural, or nutritional dependence on these resources. So I was delighted to be able to participate, but I want to just say it, if I haven't made it clear already, I'll try to make it clear 2 or 3 more times. We weren't able to really get very far down the road of making all these linkages, and I think the main thing we can say, or the main thing I can say about writing this paper, is that we tried to set a potential pathway forward that other people can pick up on and follow in the future as more data become available and as more creative minds can start to think about how to put the data together. So the paper that I'm going to recap, and really only half of it, is available. It was published in a peer-reviewed journal, which I think is mostly behind a paywall, but there is a free version of the paper available from the Institute of Social and Economic Research, ICER, website. That link is given at the end of this slide deck, and I'm hoping or assuming, looking at Nikita, that the slides will be posted under the forum's website, so you can get at the full paper if you want that way. It is a long and very tedious paper. I've never been able to read it myself in one sitting. I don't think I've even made it through the whole thing. But it does a really at least to my way of thinking, a remarkable job of trying to mash together all these different kinds of data and see if we can make them work with each other even a little bit. So the part I'm going to be talking about is mostly the economic and social effects, but there is a big chunk that to me is fascinating, linking all this stuff about the omega, the saturation state, to the geography of where it might be most critical and changing the fastest, and all this interesting summary of the chemistry, at least as it stood back in about 2011. So the kernel of what Jeremy set out to have us all do, his team of loyal followers, or his merry band of colleagues, was to do something by way of a risk assessment. And the way we were figured out, the only way we could really hope to do it was by constructing an index. And an index is just a sort of a, maybe it's a lame way of saying we really can't provide absolute numbers, so we're going to put things on a sort of a scale from lowest to highest and see where communities or regions fall relative to each other. That's as far as we're able to go, and that's why we're using this idea of an index. And an index is also a sort of an underhanded way of saying we're going to mash together a bunch of data in a way that we decide we can do without having any really good reason for doing it in a particular way. In other words, there are many, many ways you could take the underlying data that we used and mash it together to create an index of this or an index of that. And so we had to pick one, and we decided to piggyback on the framework that was developed by the Intergovernmental Panel on Climate Change, SREX. I believe it stands for Special Report on Extreme Events. Anyway, acronyms everywhere, but this was a framework that had been adopted by a large group of scientists, so we decided, well, we'll just follow along and use their framework. There are other frameworks. My former colleague and good buddy Aaron Poe knows of some of them, and Aaron, I'm happy to say we departed. In this paper, we depart from the one that you had us going on for the Chugach Forest. Just a friendly way of saying that there are many different ways of doing this. They've all got their own acronyms, and they all use some of the same words, sometimes to mean different things. The words typically interchanged are resilience, adaptation, vulnerability, exposure, sensitivity, and maybe 5 other ones. So I'm going to try to at least sketch out how we used the words here and what we came up with by doing so. So at the center of this framework is the idea of risk, and they used, or the IPCC folks used, disaster risk, and I guess disaster might not be quite the right word for what we're thinking about, but it would be significant negative or significant consequences to our well-being from ocean acidification. That would be the white circle at the center. And we collected and mashed together data on the 3 components set out by the IPCC, known as the hazard, the vulnerability, or I should go in a slightly different order. The hazard, the exposure, which I think means to what degree are we humans exposed to the hazard, and then how vulnerable are we for a given amount of exposure. So I'm just going to walk quickly through the kind of data that we use to try to measure each of these 3 colored components, and then what happens when we mash it all together. I don't think this is going to take much more than another 5 or 7 minutes. So if you're fading, just set your timer for 5 or 7 more minutes and we'll make it. And then for those who are fascinated by it, we can talk together about this because it really raises more questions than it answers. So we're basically gonna multiply numbers together for each of these 3 colored components: hazard, exposure, and vulnerability. And we're further going to break down, and this is where it really becomes arbitrary, I think, how you use these different words. But in this framework, we're going to break down one of the components, vulnerability, into something that we're calling sensitivity and adaptive capacity. And to my way of thinking, these 3 colored parts of the equation, or parts of the picture, break down along the line of chemistry. Is the hazard, how bad is it going to get? How bad is that saturation state going to get? Exposure is, to what extent are the important commercial and subsistence fisheries going to be affected by the changing chemistry? And then vulnerability takes us out of the realm of fisheries and ecosystem services and into the larger picture of our overall economy and well-being, because fish isn't everything, at least for most of us. And we do have a larger world that we live in, and we have ways to cope with changes, even if they're bad changes, in the abundance of the fish. Now, this next 2 slides are just excerpts from the paper intended to remind us that if you look across Alaska's 26 or 27 boroughs and census areas, maybe it's 28, I can't remember, there's a perhaps a surprising, perhaps not surprising, degree of variability in what we catch and use just when we do catch fish, and therefore a potential significant variation across the state in how vulnerable our commercial fish revenues are to ocean acidification. And I think the idea here is that salmon and shellfish, the blue and the red, are species of higher vulnerability than other finfish, and groundfish aren't even on this graph. I'll just say right up front, one thing I learned from reviewing for this presentation is that we really did a lousy job of integrating the data for the Aleutians, which really is a special case in fisheries because of the importance of the groundfish resource. I don't think it's even in this graph, which is highlighting the differences in the importance of salmon and shellfish versus other finfish. But the 3 Aleutian areas are in the orange oval towards the right, and you can see what most of you already know, that if you're in the Lake and Penn Borough, you're a salmon. Your commercial fishery is based mostly on salmon. And if you're in the Aleutians, it's based largely on shellfish and other stuff. And there's similar variability across the state in the subsistence catch or and use of, this is just of fish. The different kinds of fish vary quite a lot. And so this variability is what we thought would make it at least somewhat interesting to construct this index for each region of Alaska. So we end up with 28 or so values for it. Even if it's just relative to everybody else, we thought this might be useful information to see how different regions are more or less vulnerable compared to others. Now, this is a conceptual, conceptual diagram of all the different places or pieces of data that we pulled together to try to get to the ultimate goal, which is the risk index up in the left-hand corner. And for many of these pieces, there's actually multiple data points or multiple data series that even go into the pieces. So you end up with just a lot of different data all mashed together. And as I've already said, anytime you do these exercises of constructing indexes, it's all a matter of judgment and not really guesswork, but there's a lot of art to it as much as science. And if you did it, you'd probably come up, or if we had a team composed of this half of the room, they would probably come up with a significantly different index than a team from this half of the room, even if given exactly the same data. It's just the way it works. So it's not worth quibbling about the details of how any particular index is constructed unless you think there's unless you spot something that you think is a fatal flaw, in which case I think we'd all love to hear about it and love to talk about it. So here's the part that goes really fast. The hazard index came from Jeremy and the chemists, and it was all based on this projected decrease in the saturation state that we just heard about in the last two speakers. And we were only able to do this for 4 ocean regions, and I can't even remember which region has the worst or the most significant projected decline. But I could look it up for you if you want. Turning to exposure, we did economic exposure by looking at basically to what extent is your commercial fisheries revenue dependent on shellfish and salmon. So I've tried to put in the Aleutians West census area data for all of these examples and a comparison to some other place. But here's a difference where the Aleutians West is dependent on crab, shellfish, not so much on salmon, and the Bristol Bay Borough is dependent really not at all on crab and completely on salmon. They end up with the same value for exposure, but it shows you how you could get pretty different exposures if you had different dependence on shellfish versus salmon versus other stuff. Subsistence, which ended up having the buzzword nutritional, I think that was what we thought would work better in a peer-reviewed journal, was also measured in sort of roughly the same way. And again, this is a measure of your exposure to vulnerable fish species relative to other fish. It's not salmon and shellfish relative to your entire subsistence harvest of fish, mammals, birds, and berries. It's shellfish and salmon relative to your total fish. Now things get really dicey, and I can barely remember how we did this, and I even get confused when I look at my spreadsheet. But we started lining up data on things like fish processing employment, fish processing wages, share of the total population working in commercial fishing or fish processing. And in each of these cases, we had to turn everything into what we call quartiles, meaning we line up all the data, like if we lined ourselves all up against the back wall and we cut ourselves into 4 slices based on our height. Those would be 4 quartiles. So this is what we did for a lot of these data. We just placed them into, are you in the top quarter, the bottom quarter, or one of the middle quarters relative to the other regions of the state. And we just, here we're really starting to mash together data in a sort of an arbitrary way. So for example, we decided that the best way to represent economic sensitivity, which means to what extent is your economy hitched to fishing, if you will, and we did that by mashing together the average revenue per worker who is working in the fishing industry with this idea of really the share of the population that's working directly with salmon and shellfish, the OA dependent or the OA vulnerable species. And it's not worth trying to understand the details of all these calculations, trust me, but I'd be happy to talk about them with you afterward at any time. And we did the same thing for on the subsistence side, mashing things into quartiles, and also looking at, it's not really shown here, but we have an index of total, well actually it is shown here, just the total pounds of fish per capita that are caught and used for subsistence as an index of how dependent you are. And the last thing where it gets really exploratory or dicey, in my view, is when you start to talk about adaptive capacity. So here we're talking about positive things that could counterbalance a negative effect of ocean acidification. And we're looking for things like diversity of the economy, the educational attainment of the population, the poverty rate backwards. So if you're not poor, that's good. You're assumed to be more adaptive. And if you're more poor, you're going to have a tougher time adapting. And again, we just line up all 28 regions and turn them into quartiles. So we mash all these pieces together, mostly in the form of these quartile slices together, and then we just rank them from most at risk to least at risk. That's how the graph works. And not surprisingly, at the top of the list is the Lake and Penn Borough, heavily dependent on salmon, right? And at the bottom of the list is the North Slope Borough, not really known as a fishing economy. So to a great extent, this list breaks just the way you might expect it to if you sat down and, being knowledgeable people, wrote about which regions are more or less dependent on fishing, or salmon for that matter. But there were some surprises, and I'll just highlight two of them, and then I'll be done. One surprise, this is a picture of the graph. One surprise is that Anchorage actually turns out to have a relatively high ranking for being at risk from fisheries-related ocean acidification. Now, you could argue that that's just an artifact of how we did this particular index, but nonetheless, I thought it was we who've looked at it thought it was kind of interesting. And the reason is that there's actually a lot of permit owners, boat owners, and part-time fishers who live in Anchorage but depend on, I would assert, mostly the salmon resource, maybe the crab to some extent. And the average income for these people is quite high relative to other people. I guess there's a lot of boat owners and skippers there. And the share of acidification susceptible fish is also pretty high. So Anchorage ranks surprisingly high on our risk index. Kodiak ranks, I would say, surprisingly low. It's in the middle of the pack, but I think lower than you would have guessed if I'd quizzed you at the beginning. And that's largely because of the importance of, I think I might have said this slide, I might have misstated on this slide, but one of the things that's causing the relatively low ranking is the dependence of people on marine mammals and other species for subsistence. They're not really as tightly dependent on acidification susceptible fish. And that immediately leads to a potential strategy for coping of, well, one way to cope with ocean acidification is not to deplete all the other species that people are dependent on, like the mammals. But I'm sort of getting beyond the scope of the paper. And the other surprise, I think it's a sort of a minor surprise, is that the West Aleutians census area is also down there in the middle of the pack and not as high up as you might expect, especially given the other two, Aleutians East and Lake and Penn, are right at the top for the risk index. But I guess it's not really that much of a surprise when you unpack the index. There's some statistical issues about how we constructed it that might have given a low result. But I think the basic story is that Aleutians West is heavily dependent on pollock, and pollock right now is not deemed, or was not deemed for this framework, to be particularly vulnerable to acidification. If pollock turns out to be vulnerable to acidification, that would catapult West Aleutians right to the top of any kind of risk index, no matter how you cooked it up. So that's really the end of the recapitulation. And my takeaway from this is, number one, my second bullet, which I'm not sure it's happened yet, but we still hope it will, that other people will pick up this way of reasoning and try to move the ball forward, use newer data and better data to try to do this exercise in a much more rigorous, comprehensive way than we were able to do it. And then the other thing is the first bullet. We're really not that far apart across the state in our risk from ocean acidification to fisheries. We're really all in the boat together. And even places like Anchorage, which may like to think of itself as, you know, the land of retail stores and oil industry profits, could care less about ocean acidification. Well, in fact, even when you do an index the way we did it, Anchorage comes out as potentially quite at risk. So that's my big takeaway, that we're all in this together, and we all need to work together. No region can afford to think that they're not vulnerable and that we shouldn't be helping each other out addressing this problem. Thank you.